So we did a question for November 2019. So we can check some more other questions. We can now go through some other more questions in relation to how to calculate the expected returns, how to compute the standard deviation, and also how we can be able to compute the coefficient of variation. So the next question I want us to go through, the next question we can go through, we can check May 2021. May 2021. There is a question number 2, part D. We can check the question for May. We can check the question for May 2021. Question number 2, part D. Question 2D. We can check the question number 2, part D. So that question 2D, you are given the past tense. Then when you can check the past, we can share them. Let me share them for the class group briefly. So when you check through the question number 2, part D for May 2021, the question simply asks you that Eliud is considering, we have found the question. So we can go through that question. The question reads that Eliud is considering investing in security A and security B in equal proportions. The following forecast have been provided. So they gave you the stage, recession, stable, and expansion. They have also given the probability of each one of them occurring, returns in form of percentages for share A and share B. So required expected return for the portfolio, then also the standard deviation for security A. So what I want us to do now, we shall first calculate expected return for each. I will not compute for the portfolio. We had already discussed that our portfolio is a combination of the two. But first, we shall be calculating for each. So starting with security A. So remember, expected return is the same as the average return. Expected return are the same as the average returns. So if you want to compute expected return for A, we simply take the summation from the first observation to the last. There are 3 observations. Those state of economy, there are 3 of them. recession, stable, and expansion. So n is 3. So you take the return for n multiplied by the probability. Then you will add them together. But now the first return for n, they gave you 12 multiplied by the probability of it occurring, which is 0.3. You add. The second return is 15. We multiply by the probability of it occurring, which is 0.3. Probability of it occurring is 0.3. Then the last one is 10. Probability of it occurring is 0.3. So that now should be able to give you the expected return for A. You add them. You take each return multiplied by the probability, also the other return multiplied by the probability. So this one should be 4, not 3. This one is 0.4. Should add up to 1. So that now compute. It will be able to give us the expected return for A. Then you do the same for B. We do the same for B. Expected return for B. You also get the summation from the first observation to the last. So you get the return for B multiplied by the probability for each. The first return for B, it is given as 6, also multiplied by 0.3. The second return for B, it is 7.5. 7.5 multiplied by 0.4. The last one is 9.5, also multiplied by 0.3. So that should give you the expected return for A and B. Should be able to give us the expected return for A and also for B. So you simply take each return multiplied by the probabilities. The first one has given us which percent? 13.19. 19.9. You produce 100. Because all of them are less than 15 and below. So when you multiply the probability, it must be less. $12.6. So the first one is 12.6. How about the second one? The second one is 6.3. So that is expected return for each. I'm not computing that for the portfolio because I've not shown you about the portfolio. So I'm first calculating for the expected return for each security. Then when we go to normal letter 2, they wanted you to get the standard deviation for N, but we shall calculate for both. So we start with the standard deviation for N. So to come up with the standard deviation for N, when you want to calculate standard deviation for N, it is simply the summation from the first observation to the last. There are 3 observations. So you take the return for N minus expected return for N. You square, then multiplied by the probability, then we shall come up with the square root for that. So the first return for N The first return for A, we know it was 12, minus expected return, 12.6. So the difference is square multiplied by 0.3, like that. We go to the second return for A, which is 15. You also minus expected return 12.6 square, then 0.4. The last return for A, it is 10. You also subtract 12.6 square, 0.3. So get the total for that, then you get the square root for it. So you simply take each return, subtract the average return or expected return. Then when you add all of them together, you get the square root to give you the standard deviation. When you add all of them together, you get the square root in order to get the standard deviation. Then you do the sum for B. We shall also be required to calculate the standard deviation for B. The summation from the first to the last. So return for B minus expected return for B. You square, then multiply by the probability. You also be coming up with the square root of that. So the first return for B, it was 6 minus expected return 6.3. You square, probability is 0.3. The next return is 7.5. You also minus 6.3 square, 6.4. The next one is 5. Also minus 6.3 square, 0.3. So the total also get the square root so that we come up with what is supposed to be the standard deviation for each. So that we come up with the standard deviation for each. So what should we have for A? The total for A before you got the square root is which value? So you got 4.44. So that when you get the square root, you give us 2.107. Then total ya hii ingine inakuja ngapi? 1.11. So that we end up getting 1.054. Yeah, so that should be the standard deviation for each one of them. But the question wanted for only A. But now that we are learning, we have calculated for both. Then the other thing I would also like us to compute is the coefficient of the variation. The question did not ask, but normally when you are dealing with this part of the topic, you are looking at three measures of risk. One of them was expected return. The second one was the standard deviation. Now we also calculate coefficient of variation. So coefficient of variation is also a measure of risk, whereby we get the standard deviation, then we divide by the expected returns. So we can also now compute coefficient of variation. We can now also come up with the coefficient of variation. So coefficient of variation is simply given by, let me compute coefficient of variation for A. You simply take the standard deviation for A, divide by the expected return for A. To calculate the coefficient of variation for A, you simply take the standard deviation for A, divide by the expected return for A. So standard deviation for A, you have 2.107. Expected return for A, it was 12.6. So that is coefficient of variation for A. There is also coefficient of variation for B, where you take the standard deviation for B, also divide by expected return for B. The standard deviation for B, you got a figure of 1.054. Expected return is 6.3. That's now how we should go about to compute the expected return for A and also the expected return for B. So sometimes they normally ask you to advise which one is the best. So when we are using the coefficient of variation, you see it has combined both expected return and the standard deviation. So we normally pick the one with the lowest. We normally select the one with the lowest. So which one has the lowest coefficient of variation? So the one, they are the same. Yeah, but anyway, they did not ask. They did not ask. But usually we use the three of them. The first one, we use expected return. So check the expected return. Which one is the highest? Obviously, it's A. Yeah, so we pick the one with the highest. Then, when you are using the standard deviation, you pick the lowest. So when you are using the standard deviation, you normally pick the lowest. So the lowest now turns out to be B, isn't it? But now we go to coefficient of variation, whereby it has now combined both. But now you are saying the same. Yeah, so finally we are indifferent. So the question did not ask, but ordinarily you pick the one with the highest. So I think that's why they never ask you to make a decision on the basis of that. So after learning about that question, I still want us to get another question. I still want us to get another question. I still want us to get another question. So the next question I would like us to go to. The next question I would like us to go to. So we go to the one for December 2021. December 2021. December 2021. December 2021. There's the one for the pilot paper. December 2021. December 2021. Question 5, part A. Question 5, part A. There are 2 Decembers. The one for the pilot paper and the one for the real exam. So check the one for the pilots. They have indicated as pilot December 2021. We got to question number 5, part A. Pilot December 2021. Question number 5, part A. I hope you can see the question for Utawala Limited. Yeah, so let us go through the question for Utawala Limited. The question number 5, part A, it was a pilot paper. A pilot paper is a transition paper for the syllabus. So the question reads that Utawala Limited plans to buy shares of MCorp Limited that are currently selling at least 20 each at the National Securities Exchange. At the National Securities Exchange. The forecasted price per share and the probability of their occurrence on different states of nature are as follows. So they gave you the state of nature, excellent, normal, poor, and very poor. They gave you probability. They have also given us forecasted share price in shillings. Remember, we require returns. We don't require the share price. So I will be converting the share price into the return. I will be converting the share price into return. So required Roman letter 1, expected return of the company share, Roman letter 2, standard deviation of the returns. So always I want you to remember, when you are given the share price, convert them into percentage returns. Convert them into returns. So to get a return, we normally compare the price at the beginning and the price at the end. The difference will give you a return. The return can either be a gain or a loss. You see, when you buy the share in the stock exchange market, when you buy the share at the stock exchange market, at the end of the year, you are paid some returns. The excess of the price that you pay to acquire the share and the current selling price. That now will be our return. But we require it in form of the percentage return. So this is how you will be calculating the percentage returns. This is how you will be computing the percentage return. So to calculate the percentage return of the share, percentage return, percentage returns, it is given by P1 minus PO. You also divide by PO, then you express it as a percentage. So P1 is the price at the end of the year. PO is the price at the beginning of the year. Then the base remain the price at the beginning of the year. So we get the increase in return. So we compute for each state of economy. We compute for each state of economy. You start with the excellent. You start with the one for excellent. When you check the one for excellent, P1 is 25. Then PO was given in the first paragraph. You see that currently selling at how much? At 20 in the first. So you minus 20, also divide by 20, express it as a percentage. That's now for excellent. Then there is also the one for the normal. There is also the one for normal. Normal, you take 22. PO is still the same. You also divide by 20, get the value for that. The next one is poor. The next one is poor. So for poor, it is 21 minus 20, divide by 20, you express it as a percentage. The next one is very poor. So very poor, it is 19, also minus 20, also divide by 20. Then we express them as percentages. Always remember, when they give you the share price, convert them into returns. To get the returns, you take the price at the end minus the price at the beginning. So the price at the beginning is what it is currently selling. Then at the end, they have given you the forecasted share price after 1 year. So when you check, the first one has given us which percent? So the first one is 25. How about the second one? The second one is 10. How about the third one? That one is 5. The last one is a negative. Negative 5. Those are percentage return for each. But now after that, we get the expected return. We now get, so we can assume it is share X. We can assume it is share X. We want to get expected return for X. So you get the summation from the first observation. So here the N is 4. The number of observations are 4. There is excellent, normal, poor, and very poor. So take return for X multiplied by the probability for each. So the first return for X, it is 25. We have just calculated up there. The probability of it occurring, it is 0.3. Then you add the second return for that share is 10% that you have just calculated up there. Probability of it occurring, it is 0.2. 0.2. Then there is also 5. Probability of it occurring is 0.35. And finally, the last one, it is negative 5. Probability of it occurring, it is 0.15. So that is now our Roman letter 1. The expected return for the share. That is now the Roman letter 1. The expected return of the share. So that now will give us the expected return. That's how I. Just giving us here. 10.5. Yeah, so once you get the 10.5, now we go to the Roman letter 2, where we compute the standard deviation. Now go to the Roman letter 2. How to calculate now the standard deviation. You want now to calculate the standard deviation. can now compute the standard deviation. So standard deviation for x, get the standard deviation for x. We get the summation from the first to the last. There are 4 observations. Return for x minus expected return for x. You square, multiply by the probability, then get the square root. Get the square root. Get the square root for that. So for us to get the standard deviation for x, we get the return for x minus expected return for x. Then we square, then the probability. So we have all the information so far. The first return for x, it is 25, minus expected return, which is 10.5. We square. The first probability was 0.3. The second return, it is 10, also minus 10.5. You square. The probability is 0.2. The third was 5. You also minus 10.5. We square. The probability is 0.1, so that's 0.35. Then the last one is -5. We also minus 10.5 square, then 0.15. That total, you will get the square root. So that now you get the standard deviation for that share x. So that we come up with the standard deviation for share x. So that we get the standard deviation for share x. You add them together, then get the square root of the value. So we get the total, then we get the square root for that. The total is 109.75. So you have 109.75. When you get the square root now, give us 7.48. So that is the standard deviation. So I will still want us to compute the coefficient of variation, though the question did not ask, because we have 3 measures of risk: expected return, standard deviation, and the coefficient of variation. So that's the order they normally ask. So coefficient of variation for share x, you simply get the standard deviation for x, divide by expected return for x. When you want to get the coefficient of variation for x, It is the standard deviation for x divided by expected return for x. So standard deviation for x is 10.48. Expected return for x, it is 10.5. We have already calculated that expected return. So now you come up with what should be the coefficient of variation. That now will give you the coefficient of variation. That now should give us the coefficient of variation. So now after that, I want us to have a brief subtopic. We can now write something about a subtopic as measures of the relationship. We now look at the measures of the relationship between the security returns. Now we can have a subtopic as measures. Measures of the relationship between security returns. We can now look at the measures of the relationship between the security returns. Measures of the relationship between the security returns. Measures of relationship between security returns. There will be two of them. We shall be discussing them one by one. We shall discuss them one by one. Discuss them one by one. So we start with number one. Number one should be covariance. Number one is meant to be covariance. Number one is meant to be covariance. The first one will be the covariance. So just for an explanation, when it comes to the covariance, we shall be showing whether the relationship between the two security is positive or negative. That's now the covariance. So I had already explained the relationship. I gave an example. Let's say the weather is the problem and we want to pick an investment. So the investment you want to pick is whereby you remain in business always. So a brief example is I can be selling in my shop either the pullover, the umbrella, or the ice cream. So the weather is the problem. So if weather is the problem, which is making me to be in business, when it is raining or cold, people will buy clothes like now the pullover or the umbrella. But when it is too hot, now they will resort to ice cream. So when I'm combining, I either combine the umbrella and the pullover or the umbrella or pullover with the ice cream. So if I pick the pullover and the umbrella, all of them are on high sale when it is raining or cold. So when it is cold or raining, all of them will go up. Yeah, pullover and the umbrella will go up when it is specifically raining. So that is a positive relationship. All of them will either go up when it is raining, or all of them will go down when there is no rain. That's now a positive relationship. But if I pick the pullover and the ice cream, when it is raining, pullover will go up, but the ice cream will go down. That's a negative. They go to the opposite direction. So we were explaining that for a better minimization of risk, I want to be in business always. So I pick a combination whereby when it is raining, I'm able to sell. When it is too hot, I'm able to sell. That's now a negative relationship. But there is also a positive. So the covariance will be telling us whether the relationship between the two security is positive or negative. So that's now when it comes to the covariance. So we can summarize something brief on it. We can write that it indicates whether there is a positive or negative relationship it indicates whether there is a positive relationship or negative relationship between the security returns. So it indicates whether there is a positive or negative relationship between the security returns. It can be expressed as follows. 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 So if I want to get covariance between security A and B, I've chosen A and B to be my securities. So to get the covariance between A and B, I will be getting the summation from the first observation to the last. So N is the last observation. So I take return for A minus expected return for A, like that. Then I multiply by return for B minus expected return for B. Then once I've multiplied them together, then I multiply by the probabilities like that. So to get the covariance between A and B, first get the returns for A, subtract expected returns for A. Remember, expected return is the average or the mean. Then also check the return for B minus the expected return for B. Once you get the difference between the two, multiply now this one and that one. Then, because they are subject to probabilities, multiply by the probability. When we add them together, we shall be able to know whether the relationship between the two has been positive or negative. That's now what we should be doing when it comes to that table. So I will pick a question. As we go through each one of them, we use an illustration from the question. I want us to pick a question for November 2018. So let us get a question for November 2018, question number 5, part C. November 2018, question number 5, part C. I want us to check in the question, November 2018, question number 5, part C. November 2018, question 5, part C. I hope in the end, by the end of next week, you'll have your past papers. They were combining them together, but they have sent them to the class group before they make a copy for you. They had sent some copies to the class group. So I was asking you to check November 2018. When you check November 2018, question number 5, part C. November 2018, question number 5, part C. So that question 5, part C, I hope you have seen it. Daima investment. Yeah, so the question is, Daima Investment Bank has provided the following information relating to the two of its securities, namely A and B. Namely A and B. So, state of economy, probability, and security returns are given. So they gave you the state of economy as stable, expansion, and recession. So there are 3 states of the economy. Then probability of occurrence, they have given you 0.3, 0.4, 0.3. Security returns, we have seen the question. It is on which page? Page 43. Confirm page 43. Online, you have found the question. So they gave you security returns for A and also for B, stable, expansion, and recession. So required Roman letter 1, they would like you to calculate expected return for each security, which you have already learned. Roman letter 2, standard deviation for each security. Roman letter 3, correlation coefficient. So correlation coefficient will be number 2. When you will be listing them, we have started with covariance. The next one will be correlation coefficient. But before you calculate correlation coefficient, you must first get the covariance. Before you get the correlation coefficient, you shall first calculate the covariance. So I want us to start with the Roman letter 1 of the question. We calculate expected return, then we shall also calculate the covariance now after that. So to get the expected return for A. Remember, you just take the summation from the first to the last. So here there are 3 observations. Take return for A multiplied by the probability of it occurring. So here they gave us percentage returns. A is, the first one is 12. Probability is 0.3. The second one is 15. Probability is 0.4. The next one is 10. Probability is 0.3. So when you add them together, they will give you expected return for A. Then we also calculate expected return for B, where you also get the summation from the first to the last. N is 3. So return for B multiplied by the probability for each one of them. So the first return for B, it is given as 6. Probability of occurrence is 0.3. The next return for B, it is 7.5 multiplied by 0.4. Then the last one there is 5 multiplied by 0.3. So the first one has given us which percentage? Sorry? 12.6. How about the second one? 6.3. So now after this, I want us to get the covariance. You see the formula for the covariance between A and B. So let us now get the covariance between A and B. So there are 3 observations. We start with the first observation. So I start with the first return for A minus expected return for A. So my first return for A, it is 12. So I take 12 minus expected return for A. Our expected return for A is 12.6. So I subtract 12.6. Then you remember this one, the return for B. So I also start with the first return for B, which is 6. Then I also subtract expected return for B, which is 6.3. Then after that, you also multiply the probability. So the first return is 0.3. We multiply by 0.3. So that's now the first one. You also go to the second one. This one is 15, also minus 12.6. Then this one is 7.5, also minus 6.3. Then 0.4. Then the next one is supposed to be 10, also minus 12.6. Then also 5 minus 6.3, then 0.3. So when you add those figures together, that is what will give you the covariance between A and B. That is now what will be able to give us the covariance between A and B. That now will give you covariance between A and B. You are getting 2.2. 2.22. Yeah, so that should be now the covariance. So I would still want us to answer the Roman letter 2 of the question. So Roman letter 2 of the same question, they wanted you to get the standard deviation. The Roman letter 2 of that question, you see the standard deviation. Yeah, so let us also calculate the standard deviation. Let us now also compute the standard deviation. You already know how to get the standard deviation from the previous 2 questions that you are able to settle on. You also know how to calculate the standard deviation for the previous questions that we did. So now to get the standard deviation for A. So for us to get the standard deviation for A, for us to come up with the standard deviation for A, simply get the summation from the first to the last. So return for A minus expected return for A. So that difference we square, we multiply by the probability, then you get the square root. So when you want to compute the standard deviation for A, you simply come up with those details. So the first return for A, it is 12, minus expected return, which is 12.6, you square. The probability is 0.3. The second return for A, it is 15. You also minus 12.6, you square 0.4. The last return is 10 minus 12.6, you square, probability is 0.3. So add them together to get the standard deviation for A. Then you get the square root. Get the square root for that.
They have another business. Farming business. So you don't mix. The other aspects
They have some several decimal places. You can have them into 3 decimal places. That's the case. That's the case. So here we are coming up with which figure? Then B. Yeah, so we have 2.1, 2.11, I'm at 2.107. Okay. To do decimal place. The other one is 1.05. So that will be able to give you the Roman letter 2. So we were looking at the measures. The first one I've given the covariance. So I want us to go to the second measure, which is the same as your Roman letter 3 of the equation, correlation coefficient. So let us go to the measure number 2. Measure number 1 was the covariance. But there are some items we have calculated about them. Remember, you already know how to get expected return under the measures of risk, how to get the standard deviation under the measures of the risk. So we go to the measure or number 2, which will be correlation coefficient. Let us now go to the measure number 2 as the correlation coefficient. We go to the measure number 2 as the correlation coefficient. So number 2 should be the correlation coefficient. Correlation coefficient. So we got the measure number 2 as the correlation coefficient. So for the correlation coefficient, we can simplify something brief in relation to that by writing that it indicates the extent. It indicates the extent of the positive or negative relationship. It indicates the extent of the positive or negative relationship. The extent of the positive or negative relationship. So it has a meaning. So you are indicating that it indicates the extent of the positive or negative relationship between the returns of the two securities. 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 It is expressed as follows. It is expressed as follows. It is expressed as follows. So I will be using R to represent the correlation coefficient between A and B. I will use R to represent the correlation coefficient. So it is supposed to be given by covariance between A and B divided by the standard deviation for A multiplied by the standard deviation for B. When you want to get the correlation coefficient between A and B will simply be equal to covariance between A and B divided by standard deviation for A multiplied by the standard deviation for B. So the standard deviation for A multiplied by the standard deviation for B. So already we have calculated the covariance. But in here, 2.22. Yeah, so you take 2.22 standard deviation for A to measurement 2.1. 2.11. Then the standard deviation for B, it was 1.0. 1.05. We get a value of that. So we show it as +1. So we show it. So when you round it off to 2 decimal places, it ends up with 1. Yeah. So we show it as positive or negative. So this one is +1. So that should have been your Roman letter 3 of the question, where they were asking you to calculate correlation coefficient between the two securities. That's now our Roman letter 3. But before we proceed, still on the same, I want us to write something more on that. I want us to write something more in the notes. So the next paragraph, we write that the correlation coefficient normally range. The correlation coefficient normally range from -1 to +1. It normally range, you get this way, it normally range from -1 to +1. It normally range from -1 to +1. Then a new paragraph, we also say that, +1 means that the two securities, +1 means that the two securities are perfectly positively correlated. +1 means that the two securities are perfectly positively correlated. The two securities are perfectly positively correlated. And if they are combined, a continuation, if they are combined to form the portfolio, and if they are combined to form the portfolio, and if they are combined to form the portfolio, there will be no risk minimization. If they are combined to form the portfolio, then there will be no risk minimization. If they are combined to form a portfolio, then there will be no risk minimization. That's now what we mean by +1. Another paragraph, we have it as -1. That -1 means that the securities are perfectly negatively correlated. -1 means that the two securities are perfectly negatively correlated. They are perfectly negatively correlated, and if they are combined to form the portfolio, and if they are combined to form the portfolio, and if they are combined to form the portfolio, then there will be 100% risk minimization. If they are combined to form the portfolio, then there will be 100% risk minimization. There will be 100% risk minimization. There will be 100% risk minimization. So that's now the meaning of +1 and -1. Then another paragraph, we summarize that if the correlation coefficient is positive, if the correlation coefficient is positive, then the standard deviation of the portfolio, will be the weighted average. If the correlation coefficient is positive, then the standard deviation of the portfolio will be the weighted average. Then the standard deviation of the portfolio will be the weighted average. So what we simply What we are simply explaining there is that if correlation coefficient between A and B is positive. So if it is positive and you want to calculate the standard deviation of the portfolio. So standard deviation is normally the sign for the standard deviation. So standard deviation for the portfolio. Remember, our portfolio is now a combination of the two. They have given you security A and B. When you combine them together, they form our portfolio. So you have to get the combined standard deviation. So it will simply be the weighted average. It will simply be the weighted average. So to get the weighted average, you take the weight of A, standard deviation for A, and you add the weight for B, then also the standard deviation for B. So when I want to get the combined standard deviation, we have already calculated standard deviation for A and B, but we want to combine them together to make it one. So combining it, because this relationship was positive, it will be the weighted average. To get our weighted average, we take the weight for A. Weight is the proportion. Weight is the proportion in which they have combined. So I take the proportion for A, multiply the standard deviation for A. Then now plus the weight for B, the proportion of B in the combination, also multiply the standard deviation for B. So going by our question, I want us to see how to calculate it. Going by our question, when you go through the question, I want you to go to Roman letter form. I want you to go to the Roman letter form. They gave you some proportions in the Roman letter form. When you check Roman letter 4, they have stated that determine the expected return of the portfolio constituting of 60% of security A and 40% of what? Security B. Those are the proportions or the weight. The proportion for A in the combination is 60%. The proportion for B in the combination is what? 14%. Remember, 60 plus 40, they add up to what? 100. So the weight for A, it is 60 divided by 100. Then you had calculated the standard deviation for A. You can check up there. Standard deviation for A was 2.11. Then the weight for B, it is 40% over 100. This one was 1.5. So finally, it is the same as 0.6 multiplied by 2.11, then also plus 0.4 multiplied by 1.45. That's now how we can be able to come up with the standard deviation for the portfolio. So the question is not asked, but I'm just explaining the concept, just in case they ask you that part in the question. But I will be using it somewhere. I will be using it somewhere. The question did not ask that part, but just in case, we should be able to apply that question. Get the percentage for that area. So inakuja which figure? 1.68. That's now how we should do it. Yeah. but you can still have the power flow to this. So that is now when it is positive. Another paragraph, we can write another paragraph by summarizing that if the correlation coefficient is negative, if the correlation coefficient is negative, if the correlation coefficient is negative, then the standard deviation of the portfolio, then the standard deviation of the portfolio will be the weighted difference. If the standard deviation, sorry, if the correlation coefficient is negative, then the standard deviation of the portfolio will be the weighted difference. The weighted difference. It will be the weighted difference. It will be weighted difference. Weighted difference. So we are now explaining that if correlation coefficient between A and B is negative, if it happens to be negative, then standard deviation of the portfolio will be the weighted difference. This time it is not the weighted average, but it is the weighted difference, whereby you take the weight of A multiplied by the standard deviation of A. But now you subtract. Now we subtract the weight of B, the standard deviation of B. So if you happen to get the correlation coefficient which is negative, but the question wants you to combine the two standard deviation, we get the weighted difference. So this question, it was positive, we cannot calculate. So it was positive. So I'm just giving the formula just in case you get a negative. In case you get a negative, we'll be doing what? Subtract. But now for this question, it was positive. We cannot calculate it. We have already calculated when it was positive. So if you get the correlation coefficient, which is negative, but they require you to get the standard deviation for the portfolio, you will be coming up with the weighted difference, where you subtract between the two. So that is now the information to do with the standard deviation of the portfolio. Then we can have another paragraph. We can have another paragraph by summarizing that the actual standard deviation of the portfolio, the actual standard deviation of the portfolio, the actual standard deviation of the portfolio, or the actual risk of the portfolio, or the actual risk of the portfolio, or the actual risk of the portfolio, comma, will be expressed as follows. Will be expressed as follows. So you are saying that the actual standard deviation of the portfolio, or the actual risk of the portfolio, or the actual risk of the portfolio will be expressed as follows. Will be expressed as follows. So this is now how we shall be coming up with. This is now how we shall be coming up with the actual. So to get the actual standard deviation of the portfolio, get the actual standard deviation of the portfolio, or the actual risk of the portfolio, or the actual risk of the portfolio, you simply take the weight of A squared multiplied by the variance of A, like that. Then we add the weight of B squared, then the variance of B, like that. Then we also add 2 multiplied by the weight of A multiplied by the weight for B. We also modify the covariance between A and B. Then you now be coming up with, you get the square root. You get the square root of that portion. So when you want to calculate the actual standard deviation of the portfolio or the actual risk of the portfolio, you simply take weight of A squared, the variance of A, weight for B squared, the variance for B. Then we also add 2 multiplied by the weight of A, weight for B, then also the covariance between A and B. So that is your Roman letter 5 of the question. This formula is for the Roman letter 5 of your question, where they have asked you to compute the risk of the portfolio. So our Roman letter 5 is what we are going to have here as compute the risk of the portfolio. So risk of the portfolio there is the same as the actual standard deviation for the portfolio. So let us see how to calculate that figure. The weight for A, we have seen is the same as 0.6. So it must be squared. Then remind me the standard deviation for A. Standard deviation for A was which here? 2.11. So you square it to get the variance. This one is the variance. Without being squared is the standard deviation. But this one should be our variance. So we square it to go back to get the variance. Then we also add the weight for B, was it 0.4? Remember it was 0.4. Yeah, but it must be squared. Then what were we coming up with as the standard deviation? It was 1.0. So you take 1.05 squared, then plus 2 multiplied by 0.6, 0.6, 0.4, like that. Then remember the covariance between A and B? It was 2.22. So 2.22. And you'll now get the square root. So inakuja the same as the weight. Should be the same as the 148. The same as the weight. Round off to the same. same as the one for the weighted. The actual and the weighted are the same, and I will confirm why they are the same. We should be able to confirm why the two are the same. So, yeah. Hapana, hiyo weighted, kuna mahali nataka nitumie, but the question is not asked. But I will get that part of the question. You want how to use it. Because they are not always the same. It's specifically for this question. And I'm going to explain why they two are the same. But they are not always the same. But for this question, they are the same because of one specific reason. But I will be able to explain that reason when we do this other part. So I want you to add their Roman letter 6 on that question. I want you to add their Roman letter 6 as the percentage of risk minimization or diversification. Percentage of risk minimization or diversification. The percentage of the risk minimization or diversification. So if you want to come up with percentage of the risk minimization, if you want to calculate, so this is now our Roman letter 6, percentage of the risk diversification or minimization. When you want to get the percentage of the risk diversification or minimization, we normally take the weighted standard deviation of the portfolio. We subtract the actual standard deviation of the portfolio. Then you also divide by the weighted standard deviation for the portfolio. Then you express it as a percentage. When you want to compute percentage of the risk diversification or minimization, you come up with the weighted standard deviation minus the actual standard deviation. You also divide by the weighted, but they were the same. They were the same. You remember the weighted average? You remember our weighted average? When you round it off to 2 decimal places, it was 1 point what? Was it 1.68? Yeah. After you get it, so you need to make a great size in the actual. Here you go 1.68. Then also when you divide by the weighted 1.68. So when you express it as a percentage, you are getting at 0. You should be able to get at 0. You should be able to get at 0. So I want you to go back to your notes. Kuna mahali tuliandika something about +1. You can see what we noted about +1. Yeah, if the correlation coefficient is +1, I say that +1 means that the two securities are perfectly positively correlated. And if they are perfectly positively correlated, there will be no risk minimization. That's why you're getting at 0. Now, we had already calculated correlation coefficient was +1. So when it is +1, they are perfectly positively correlated. When they are perfectly positively correlated, there will be no risk minimization, simply because the weighted and the actual are the same. Because the weighted and the actual are the same. So now we can conclude that, if security A and B are combined to form the portfolio, if security A and B are combined to form the portfolio, if A and B are combined to form the portfolio, then there will be no risk minimization. Then there will be no risk minimization or diversification. Then there will be no risk minimization or diversification. There will be no risk minimization or diversification. But if it happens to be -1, if it happens to be -1, hii itakuja 100%. Then if it is in between -1 and +1, hii figure pia itakuwa in between 0 and 100%. It will not be 0 always. So when it is +1, the two will be the same. When it is -1, one will be half of the other. They put 100%. Yeah. But if it is in between, that percentage will range either 1%, 2%, or even 99%. When it is in between, if the correlation coefficient is in between -1 and +1, your percentage will vary. But if it is perfect, that is +1, this one will be 0. If it is perfect, -1, this one will be 100. So they will be able to range from that, depending on the correlation coefficient. So this one was not asked in this question, but some other question will ask. Calculate the percentage of risk minimization. To do that, you require the weighted. I've shown you how to get the weighted. If it is positive, it is weighted average. When it is negative, it was weighted difference. So remember that. Then the actual unatumia your format to get the value. Then they will be able to work out for that. So before we conclude the question, I also like us to write something brief about expected return of the portfolio. We can also write something brief about expected return of the portfolio. Expected return of the portfolio. Expected return of the portfolio. We can also write something brief about expected return of the portfolio. So we can also write that the expected return of the portfolio, the expected return of the portfolio, the expected return of the portfolio is the weighted average. It is the weighted average. It is the weighted average of the individual securities expected returns. It is the weighted average of the individual expected returns. The weighted average of the individual expected returns. So it is now our Roman letter 4 of that question. It is now the Roman letter 4 of that question. Roman letter 4, they want you to calculate the expected return of the portfolio. The Roman letter 4, they would like you to calculate the expected return of the portfolio. So to compute a portfolio is now a combination. So expected return of the portfolio, it is the weighted average. It is the weighted average of the individual expected returns, whereby you take the weight for A, the expected return for A. We add weight for B, expected return for B. So to calculate the expected return for the portfolio, we get the weighted average. So the weight, you already know that 60% is the same as 0.6. So go to the Roman letter 1. You can see Roman letter 1. We got expected return for A. If you check the Roman letter 1, we calculated expected return for each security. So A was which percent? Which percent? 12.6. So you multiply by 12.6. And for B, it is 0.4. B, we got 6.1. So when you combine them together, now it becomes expected return for the portfolio. When we combine them together, it now becomes the expected returns of the portfolio. Now be able to give you the expected returns of the portfolio. Expected return for the portfolio. So that is our Roman letter form. How you are to get. So after getting expected return for each, you combine them together using the portfolio. So my next question now will be April 2022. Our next question now will be April 2022. Question number 4, part C. April 2022. There is a question number 4, part C. April 2022. Question number 4, part C. April 2022. Question number 4, part C. April 2022. Question number 4, part C. That question 4, part C, it reads that Frederick Onyango, a prospective investor, is considering buying shares of company A and company B. Is considering buying shares of company A and company B, which are currently selling at shillings 40 and 50 respectively at the Securities Exchange. He wishes to invest shillings 1 million in both companies' shares in the ratio of 6:4 for share A and B respectively. So forecasted end of the year market prices and the probabilities of their occurrence in different economic conditions are given as follows. So they have given you economic conditions, probability, end of the year market prices. Then now required expected rate of return for each investment. Roman letter 2, portfolio expected return. So that's now portfolio expected return. Then Roman letter 3, assuming the returns of share A and B are perfectly positively correlated. When they say perfectly positively correlated, they have already calculated for you correlation coefficient. It is +1. The correlation coefficient is already calculated, it is +1. So they were asking you compute the portfolio risk. So that portfolio risk, you use that for the portfolio, actual portfolio risk. We apply that part of the formula. So another challenge for the question, they gave you the share prices. You are not given returns. Normally, we should have percentage returns, but this one has given us the share price at the end of the year. But they also gave you the share price at the start. So we need to get the percentage returns first. You should come up with the percentage returns first. Then from there, now you can answer the question. So to compute the percentage returns for us, get the percentage returns, then you have to calculate the percentage returns. So percentage returns, we said it is P1 minus P4. You also divide by P4 and you show it as a percentage. For us to get the percentage returns, it is P1 minus PO. So P1 is the price at the end, PO is the price at the beginning. So we compute for both shares. There is share A and also share B. So you compute for the three states of the economy. The first one is best. So we start with the one for best. So best, you can see the share price A is 50. Then I want you to check in the first paragraph. The shares are currently selling for how much? A 40. So you minus 40, also divide by 40, express it as a percentage. That is for A, under best. Then still under best for B, you take 60. The share price for B is how much? 50. You minus 50, you also divide by 50, you express it as a percentage. That's now for best. Then there is also the one for fair. There is also one for fair. When it is fair, it is 42. When it is fair, it is 42. So 42 minus 40, also divide by 40, express it as a percentage. The other one is 50, also minus 50, divide by 50, show it as a percentage. The last one is poor. There is also the one for poor. The one for poor, it is 35, also minus 40, also divide by 40, express it as a percentage. This other one, it is 40, minus 50, also divide by 50, express them as percentages. Get them as percentages. So now, once you have computed those figures, we can now calculate the expected return for each investment. We can now get the expected returns for each investment. We can now come up with the expected returns for each investment. We can now come up with expected return for each investment. So expected return for A. We start by calculating expected return for A. So expected return for A, you simply get the summation from the first. So there are three of them. Return for A multiplied by probability. So what is our first return for A? Best we got which percent? So you take 25 multiplied by the probability, which is 0.4. Then fair you got 20% for M. It is 5% multiplied by 0.3. The last one is negative 12.5. You also multiply by 0.3. Then also expected return for B, where you get the summation from the first to the last. So return for B multiplied by the probability for each. So what was there as the first percentage for B? So you take 20 multiplied by 0.4. The second one is then how about the third one? So multiply. So now you can also compute the expected return now of the portfolio, which is the Roman letter 2. So you take the weight for A, expected return for A, plus weight for B, expected return for B. But now I want to show you how to get the weights. This time they gave you the ratios. So the weight for A, if you want to get the weight for A. So are you able to see the ratios? 6 and 4, isn't it? So for A, it will be 6 divided by the total, which is 10. So it is 6 plus 4. But they gave you the amount in shoes that were invested. You see what was invested? It was 1 million, isn't it? So when I multiplied by 1 million, it will put down 600,000. It will be 600,000. Then also the one for B. When it comes to the weight for B, the proportion for B, it is 4 divided by 10. Also, so it will come up with, so they add up to 1 million. So the ratio is the same, but I wanted you to confirm for you so that just in case, because they have given you this, they have also given the ratio. But the ratio was enough. The ratio was enough because when I come at this point, it will be 0.6 million divided by 1 million. See that part? The total is 1 million, but A has taken 0.6. Then you can remember what you have calculated for A. You have gotten which percent? 7 point. Then for B, it is 0.4 millions, also divided. So this one you multiply by what? By 2. Yeah, but now this ratio is still the same as 0.6 plus 0.4. Yeah, so we shall not attempt, so that is the Roman letter 2, but now I'm not going to attempt Roman letter 3 now. I will do it in our next class. So we are supposed to have an alternate Sanane, but sit our meet today, because we commit today nitamaliza hii topic. Na wale watakuja next watapotea kabisa because they will find. So I want us to stop it so that when we meet next week, I do 2 more questions for the benefit of those who are not in today. Because if I meet you today, I will finish the topic. But the topic is always there in every sitting. That topic, I normally start with it because every sitting, they must test something on it. That's why I've carried forward. When we meet next week, is it on Tuesday? I will do some 2 more questions, then we'll finish it from that point. Then by the time we meet, I'll also do Roman letter 3. So let us stop there for now. When we meet, so we are not meeting today at 2 because of the effect of those who are not in class. If I meet you today, I will be able to finish the topic. Then those who will be joining will be an issue to them. So we can stop there for now.